In the last class, we learned multiplication law, division law and power law in indices. Now we will learn some more rules related to indices. The first one is AB to the power n is equal to A to the power n times B to the power n. You see here the bracket. The bracket means the power n is for both A and B. So when we remove the bracket, both A and B should get the power n. Let's see some examples. Xy to the power 4. When we remove the bracket, both x and y should get the power 4. So it will be x to the power 4 times y to the power 4. Another example, 2x cube, 2x the whole cube. Let's remove the bracket. What will be the answer? It will be 2 cube times x cube. That is 8x cube. Now we'll see another example. 9xy to the power 3 by 2. Here you see inside the bracket we have 9x and y. When we remove the bracket, all of them should get the power 3 by 2. So 9 to the power 3 by 2 times x to the power 3 by 2 times y to the power 3 by 2. 9 to the power 3 by 2 is 27. So 27 x to the power 3 by 2 times y to the power 3 by 2. An interesting rule, right? Now we will see the next one. According to the second rule, A divided by B all to the power n is equal to A to the power n divided by B to the power n. Almost the same as the first one. When we remove the bracket, both A and B are getting the power n. Let's see some examples. X divided by y to the power 4. Now we will remove the bracket. That means both x and y should get the power 4. So x to the power 4 divided by y to the power 4. Another one, 2a divided by 3b the whole cube. You see here we have inside the bracket 2a, 3 and b. So all of them should get the power 3 when we remove the bracket. So it will be 2 cube a cube divided by 3 cube b cube. That is same as 8 a cube divided by 27 b cube. Right? So I hope you understood both the rules. Now we will see some more interesting things about indices. How can we represent the square root of A as an index? We can represent the square root of A as A to the power 1 by 2. Now let's check how can we represent the cube root of A as an index. Cube root of A can be represented as A to the power 1 by 3. Now fourth root of A. How will we represent it as a power? We can represent it as A to the power 1 by 4. Fifth root of A we can represent as A to the power 1 by 5. Now let's form a general rule. nth root of m. Sorry, nth root of a. How can we represent nth root of a? You got the answer, right? Nth root of a is a to the power 1 by n. Now you see, how can we represent cube root of a square as an index? Let's try, right? So let's represent it as a square to the power cube root means to the power 1 by 3. We can further simplify it using power law. So this is a square times 1 by 3. That is a to the power 2 by 3. Now let's see how can we represent fourth root of a to the power 5 as an index. We can represent it as a to the power 5 whole to the power 1 by 4. Again we can further simplify it using power law. So that is a to the power 5 times 1 by 4. That is a to the power 5 by 4. Now let's see how can we represent sixth root of a cube as an index. We can represent it as a cube to the power 1 by 6. Now we can simplify it using power law. That is a to the power 3 times 1 by 6. That is same as a to the power 1 by 2. Now let's form a general rule. How can we represent mth root? Mth root of a to the power n as an index. You got the answer, right? This one we can represent as a to the power n whole to the power 1 by m. That is a to the power n times 1 by m. That is a to the power n divided by m. Interesting, right? Now you see 1 divided by a. Here a is in the denominator or in the bottom. We have to take it to the numerator. How can we write it? How can we take it to the numerator? A means a to the power 1. So when we take to the numerator, it becomes a to the power minus 1. 1 by a square. When we take a square to the numerator, it becomes a to the power minus 2. 1 by a cube. When we take a cube to the numerator, it becomes a to the power minus 3. Now let's form a general rule. 1 by a to the power n. How can we take it to the numerator? Yes, that is a to the power minus n. So when you take a quantity from numerator to denominator or from denominator to numerator, the change of the sign of the index changes. Now you see, for example, if you want to take x cube to the numerator from 1 by 2x cube. See, you want to take only x cube means keep 1 by 2. Take x cube to the numerator, that makes it x to the power minus 3. So 1 by 2 x to the power minus 3. Now if you want to take both 2 and x cube to the numerator, means it becomes 2 to the power minus 1 x to the power minus 3. Having any doubt? Let's see another example. 1 by, if you want to take 1 by 5 square x to the power 4 to the numerator. If you are taking 5 square x to the power 4 to the numerator, both 2 and 4, both the power should change the sign. So this will become 5 to the power minus 2 x to the power minus 4. But if you are only taking x to the power 4 to the numerator, it will be 1 by 5 square x to the power minus 4. You understood, right? Now we will see the most interesting thing about indices. A to the power 0 is equal to 1. See, anything raised to the power 0 is 1. So x to the power 0 is 1. 100 to the power 0 is 1. 20 to the power 0 is 1. How are we going to get it? Let's check, right? You see here, x square divided by x square. This is same as x times x divided by x times x. So we know x square divided by x square is x to the power 2 minus 2 according to the division law in indices. So this is x to the power 2 minus 2, that is x to the power 0. Now you see we can cancel out this x and x, so this will be 1. We can cancel out this x and x, so we will be getting a 1. So 1 times 1, that is 1. So x to the power 0 is 1. Now we will solve some questions from your P1 textbook. We are going to solve questions from exercise 1D. Exercise 1D, question 1F. 3x to the power 0.5 times 4x to the power minus 0.5. We have to simplify. How will we simplify? First I will rearrange it. It's not necessary, you can just directly do it. So I'm going to rearrange it. 3 times 4 times x to the power 0.5 times x to the power minus 0.5. 3 times 4 is 12, x to the power 0.5 plus minus 0.5, that is x to the power 0. X to the power 0 is 1, so 12 times 1, that is equal to 12. Good, right? Now we will see another question. That is question J. Root x times cube root of x. How can we simplify it? Before simplifying, we can write it in the index form. So root x in the index form, we can represent it as x to the power half. Cube root of x we can represent as x to the power 1 by 3. So now what we can do? Now we can use multiplication law since the bases are the same. Retain the base, add the powers. X to the power half plus 1 by 3. That is x to the power 5 by 6. Very easy, right? Okay, let's check another question. Question number K. Cube root of x, the whole square divided by square root of x. You don't need to wait for me. You can try by yourself and check the answer. What we need to do first? First we need to write this cube root of x in the form of an index. So we can represent it as x to the power 1 by 3. So x to the power 1 by 3 to the power 2. X to the power 1 by 3 the whole square divided by root x in the index form, x to the power half. Now you see in the numerator we can apply power law. So that becomes x to the power 1 by 3, the whole square becomes x to the power 1 by 3 times 2. That is x to the power 2 by 3 divided by x to the power 1 by 2. Now we can use the division law. According to division law, x to the power 2 by 3 minus 1 by 2. That is x to the power 1 by 6. You got the correct answer? Yes, I knew you would be getting the correct answer itself. Now we will solve more problems from exercise 1D. So question number 3A. 64 x to the power 10 whole to the power 1 by 2. See, what are we going to do here? We have a 64 and x to the power 10 inside the bracket. To simplify, what we do? We remove the bracket. Once we remove the bracket, 64 will get the power half, and this x to the power 10 also will be getting the power half. 64 to the power half is 8. This becomes x to the power 10 times 1 by 2. 10 times 1 by 2 is x to the power 5. So 8x to the power 5. Very easy, right? So let's check question number B. Question number B is 5x cube minus 2x square divided by x to the power 5. What we can do here? We can just split them. So this becomes 5x cube divided by x to the power 5 minus 2x square divided by x to the power 5. Now you see, we can use division law. 5x to the power 3 minus 5, that is x to the power minus 2 minus 2x square minus 5. 2 minus 5 is minus 3. So 2x to the power minus 3. It's very interesting, right? Now we'll see question number C. 125 x to the power 12 whole to the power 1 by 3. This is same as question number 3A. So I'll give it to you as a homework. We will see how much you like these kinds of problems. Now I'll give you more homeworks. Question number D, x plus 4x cube divided by x cube. This one also you will be doing. So it's a homework for you. Now question number E, two x plus x to the power 4 divided by x to the power 4. Let's try it here, right? So what is the first thing that we need to know? What is the first thing? That is, we need to split it. So we can write it as 2x divided by x to the power 4 plus x the power 4 divided by x the power 4. See, we can just use division law here. So 2 x means x the power 1. So x the power 1 minus 4 plus x the power 4 minus 4. So this becomes 2x the power 1 minus 4 is minus 3 plus 4 minus 4 is 0. So 2x the power minus 3 plus x the power 0. That is 2x the power minus 3 plus 1. Now I'll give you more homeworks. Question number 3F, 4 by 9 x the power 4 the whole raised to 3 by 2. This is a homework. Now we have question number G, 9x square minus 5x cube divided by 3x the power 5. This one also you can try as a homework. No, I'll be doing it here. Let's see. First thing we have to do is we have to split it. So this is 9x square divided by 3x the power 5 minus 5x cube divided by 3x the power 5. Now 9 divided by 3, that is 3. X square divided by x the power 5. We can use division law. X the power 2 minus 5, that is minus 3. Minus 5 by 3. I am not going to simplify it, because if we write 5 by 3, it will be, we will be getting the answer in decimals. That will not be exact. So I am keeping it as 5 by 3. X cube minus 5. So x the power minus 2. So we have finished it. Now we will try to solve some past paper questions. Question 4. Simplify x times 2x the power minus 1 by 3 to the power 4. What we can do first? First we can remove this bracket. So this becomes x times 2 to the power 4 times x the power minus 1 by 3 whole to the power 4. 2 to the power 4 is 16. So 16x. This here we can use power law. X the power minus 1 by 3 to the power 4. That becomes x the power minus 4 by 3. Now here we can use multiplication law. So 16, x means x the power 1. So x the power 1 plus minus 4 by 3. 1. Here I put the bracket because both plus and minus coming together to avoid confusion. So 1 plus minus 4 by 3. So 16 x the power 1 by 4. It's a very easy question, right? So we will see another exam type question. Question 5. Given that y is equal to 1 by 8x cube, express each of the following. in the form kx the power n, where k and n are constants. Constants means real numbers. A part y to the power 1 by 3. This question carries 2 marks. See, what's the question? Did you understand? Y is given as 1 by 8x cube. We have to find an expression for y to the power 1 by 3 in the form kx the power n. So let's try to represent y to the power 1 by 3 in the form kx the power n. Here you see what's y? Y is 1 by 8x cube. So we can replace y by 1 by 8x cube. So instead of y, we have written 1 by 8x cube to the power 1 by 3. On simplifying and removing bracket, 1 by 8 to the power 1 by 3 times x cubed to the power 1 by 3. So this becomes 1 by 8 to the power 1 by 3 is 1 by 2. Here we can use power law. So x 3 times 1 by 3, that is 1. X to the power 1, that is x. So half x. You see here, this question carries 2 marks. One for showing the method, the step, how you have done it. The only step you need to show is this one. If you have shown this step, you will be getting the method mark, that is M1. If you have got the correct answer, you will be getting the answer mark or accuracy mark, that is A1. So by showing this step and getting the correct answer, you will be getting the full mark from the question. Now we will solve B part of the question. One by 2 y to the power minus 2. 1 by 2 y to the power minus 2. Bracket is not necessary, only y is having power minus 2. 1 by 2 y to the power minus 2. We have to represent it in the form kx to the power n. So what we do first? Yes, as we did before, we will replace y by 1 by 8 x cube. We know that y is 1 by 8 x cube. So instead of y, we will write 1 by 8 x cube whole to the power minus 2. Now what we have to do? We just need to simplify it, removing brackets. So half into half times 1 by 8 to the power minus 2 times x cubed to the power minus 2. So this is 1 by 2. 1 by 8 to the power minus 2 is 64. Here you can use power law. So x cubed to the power minus 2 will be x to the power 3 times minus 2. That is x to the power minus 6. So 64 divided by 2 is 32. So the answer is 32 x to the power minus 6. This question also carries 2 marks. So 1 mark for showing the method. The only step you need to show to get mark is this one. For showing this step, you will get the method mark M1, and for getting the correct answer, you will be getting the accuracy mark A1. I hope you will be doing all the problems from indices and I also hope you have found it very easy.